So what we are going to do here is to have, okay, let me draw it for the last time. From here to there, they said what is x. Okay, and from here to there, they said is, say, plus y. So how many y's do we have? We have this one, we have this one, we have this one, which are y's. So there are three. Can I have three here? The x's, we have this one, and we have that one. There are two, and I have two there. Okay. So when we add there, you just take x to the other side. It's going to be negative. You divide by 3. You make y the subject of the formula. It's going to be 120 minus 2x all over 3. Right. This is your first equation. And then the second equation, remember here, they say find the dimensions that x and y, that the dimensions x and y that maximize the total enclosed area. So when they talk about the area, you use the area formula. Okay, so they're not talking about the cost or anything here, they're talking about the area. So we're going to use the area formula. So it's going to be area multiplied by length and the breadth. We can see that is a 1D dimension. It doesn't have a height. We won't include the height here. So the length is x and the breadth is y. So we're gonna write our x multiplied by y there. This is going to be our equation number 2. So we're gonna substitute equation 1 into equation 2, and then we know that y is equal to this. So we're gonna substitute that 120. Sorry, 120 minus 2x all over, okay, we can see over 3 here, and over 2, over 3 here. Right, beautiful. So when we are there, the 120 divided by 3 is going to give us 40. When we multiply it by this x, it's going to be 40x. So this is going to be minus, when we multiply 2x, 2 over 3x by x is going to be 2 over 3x squared. Right, so when we are there, this is a, and then, okay, this is going to be a in terms of x. Right, so to find the maximum values or the minimum, the dimension that maximizes the surface area, or the dimension that minimizes the surface area, we have to come and derivate this. Derivate it only once. Right, so we're gonna have first derivative. When we derivate this, it's gonna give us 40, and then when we derivate this, it's gonna give us 4 over 3x, and this is going to be 0. This guy here, gonna have 0 there. 0, 40 minus 4 over 3x, and then we're gonna take this negative guy to the other side, and when it comes this side, it's gonna be positive. So it's going to be 4 over 3x is equal to 40. Right, here we're going to multiply by 3 over 4. This is going to give us 1. So we're going to come and multiply by 3 over 4 this side. This side will be left with x, and that side will be left with, this is going to be 40 multiplied by this is going to be 120, and when we divide it by 4, it's going to give us 30. Right, so this is our x is 30. Our x is equal to 30 right there. So when you found your x, that is the dimension, that is your first dimension. So let us find our second dimension, which is the value of y. By finding the value, to find the value of y, we come and substitute x here. So this, we're gonna write 30 here, and then this is gonna be 60. 120 minus 60 is gonna give us 60, and 60 divided by 3 is gonna be 60 divided by 3 is 20. Right, so we found the value of y and the value of x. Right, so in this situation you come and say the surface area will be at maximum. The surface area will be at maximum when x is equal to 30 and y is equal to 20, and y is equal to 20. Right, and you get your answers fully.